Hello students, welcome back. Today we're going to finish up section 9.3 talking about the parabola. So we're going to start by looking how to go from general form to standard form of a parabola. So general form for a parabola, there are kind of two different versions here. One of them is x squared plus dx plus ey plus f equals 0, and the other one is y squared plus dx plus ey plus f equals 0. So basically you can see that they're pretty similar after that first term. So d, e, and f are all constants. And then if there's an x squared term and no y squared term, that will be a parabola that opens up or down. And if there's a y squared term but no x squared term, that will be a parabola that opens to the left or right. So, to go to standard form, we use a similar strategy that we've used for other shapes. We're going to complete the square. But you'll notice since there's only one squared term, we only have to complete the square once for that variable. So what I'm going to do is I'm going to group my y terms together on the left side of the equation, and I'm going to move all the other stuff, the x and the constant here, the plus 5, over to the right. And then I'm going to do half of 2 is 1, 1 squared is 1, so I add 1 to that side, and then I also add 1 to this side to keep it balanced. And now I just made this a perfect square, which means it's factorable, and that factors into 1 plus 1 times 1, or y plus 1 times y plus 1, which is y plus 1 squared. And on this side, I simplified it to get 4x minus 4. Now, for standard form, I really don't want it written this way. I want like a number and then parentheses x minus something. So I'm going to actually factor out this 4 to make it look like that. And now it is in standard form. So this would be a parabola, that is centered or has a vertex at 1, negative 1. The value of p would be, let's see, 4 times p is 4, so p is 1. But that's all we had to do there is write it in standard form for this problem. Next, for now, let's take a look at another one, and let's do a lot more stuff. So we're going to write it in standard form. We're going to identify all the important parts, and we're going to graph the parabola. So first, I want, since y is squared, I want all my y's over together on one side. You'll notice, before I move this 25 over, pay attention to the fact that half of 10 is 5, and 5 squared is 25, so that is already the number that I want there, because this is already factorable into a perfect square. This is y plus 5 times y plus 5, so it looks like I'm ready to write it like that right away. And then over here, I want to factor out the coefficient here of x, so I'm going to factor out a negative 4. Don't forget that we'll change the sign here, and this will be now an x minus 1. And then now it's really in standard form. However, we might be more used to the squared thing being first, so I could just write, the right side first equals, and then the left side second to make it look like we're used to. Next thing I'm going to want to do is I'm going to want to identify the value of p by thinking, okay, 4 times what will give me negative 4, and that number will be a negative 1. So that's the value of p. And the reason that helps is I need to identify the focus, the vertex, and the equation for the directrix, and the value of p will help me do that. So I'm going to start with the vertex, which is going to be at 1, negative 5, and then p will tell me how far away the focus is from the vertex, but you have to pay attention to which direction it's going to be in. So this is where I'm going to start plotting some of the stuff that I know. So the vertex is at 1, negative 5, and then I look here and I say, okay, y is squared. That means the parabola either opens to the left or right. And since p is negative, that means it's going to open to the left, which means the focus will be to the left of the vertex. So when I move 1 to the left of the vertex, that will be the point 0, negative 5. And then the directrix will be 1 unit to the right of the vertex. Since it's a vertical line, that will have the equation x equals something, and that goes through x equals 2. So there's the directrix. And then there's another thing it asks us to do here, the axis of symmetry. That's the line that cuts the parabola in half right through the vertex and the focus. So this is a horizontal line, which it's going to mean it's y equals something, and it goes through negative 5. So this is y equals negative 5. And now to draw this graph accurately, again, one thing you can do is you can move 2p, so double that, that's -2, away from the focus. So if I move 2 units below and 2 units above the focus, you'll notice I'll find a point here that is both 2 units from the focus and the directrix. This point is 2 units from the focus and the directrix, and that's the definition of a parabola, is all the points that are equidistant from both the focus and the directrix. So that's another way to get 2 points on the parabola. Or you could plug in a number. I'm going to choose a value of 0 for y, plug in a value of 0, and I get that x is -5.25, so I could also find a point right there at -5.25 comma 0. All right, let's take a look at another example here. So write this in standard form and then find all the things and graph it. So what I'm going to do is I'm going to group my x terms together because x is squared, and I'm going to move everything else, including this y here, to the other side. So I get x squared minus 2x, and I get on the other side 12y minus 13, and then I do half of -2, which is 1, squared is 1, so I'm going to add 1 to each side. This is a perfect square, which becomes x minus 1 squared. And this simplifies to 12y minus 12. My next step is to factor out this number right here. And there's the equation of this parabola in standard form. And then from here I can identify next the value of p by saying 12 is equal to 4 times what? And the blank that's going to make that a 12 is a 3. That means p is 3. And then I can start identifying the vertex is at 1, 1. P, that tells me the focus is 3 units away from that, but I have to decide which direction that's in. So I start with my vertex here at 1, 1. And then I look at the fact that x is squared, which means it's going to open up or down. And then since p is positive, that means it'll open up. So the focus will be 3 units above the vertex. And then the directrix will be 3 units below the vertex, and since it's a horizontal line, that's the line y equals -2. The axis of symmetry goes right through the vertex and the focus. That's a vertical line, which is x equals 1. And then to graph it, I can move 2p, so double 3 is 6, and I can go 6 units to the right and left of the focus, and I will get points on the parabola because that point is equidistant from the focus and the directrix, and so is that one over there. All right, now let's take a look at a real-world example of a parabola. A satellite dish is in the shape of a parabolic surface, and that is true of all satellites. Signals coming from a satellite strike the surface of the dish and are reflected to the focus where the receiver is located. So if you've seen a parabola before, or a satellite dish before, they have this arm coming out from the edge, and then there's like a receiver on the end of that arm, and that receiver is placed exactly at the focus of the parabola. Because what happens is when signals come in, they reflect off the surface, and the point they reflect to is that receiver. And basically they put it into place so all the signals, no matter what place they hit the parabolic dish, that they will bounce directly at that receiver. So that's how a satellite dish works. So where should the receiver be placed if the satellite dish has a diameter of 8 feet and a depth of 3 feet? So basically the diameter, so from there to there, is 8 feet, and this has a depth of 3 feet. So from there to there, basically. So from like, well, I guess, boop, maybe a little lower here. From like where the top of it is to there is 3 feet. So where should this be, receiver be placed? So basically what I'm going to do is I'm going to imagine this parabola on a xy axis. So there's x and there's y, and I'm going to put basically this point right at 0, 0. That's the vertex of the parabola. And then basically I know now that this edge of the parabola will be 4 feet to the right of the center and 3 feet above the vertex, which means this is going to be at the point 4, 3 on this grid. And this point right here will be at the point -4, 3 on the grid. So let's draw a little better picture here so it's a little more clear. So here are the points that I know on the parabola that I drew. It's got a vertex at 0, 0, and then it goes through the point 4, 3 and -4, 3. The focus is what I'm trying to find, and I don't know exactly where in this line it will be, whether it will be out here or inside the dish, but I know it will have an x-coordinate of 0 and a y-coordinate of whatever p is. So now what I'm going to do is I'm going to write an equation for this parabola. Because it opens up, I know x squared is positive, or sorry, x is the term that's squared, and because it's up, I know p will be a positive number, but I don't know what p is yet. I know that the vertex is 0, 0, so I can plug in a 0, 0 there, and then I get this. X squared equals 4p times y. Now all I need to do is find p by plugging in either one of these 2 points that I know that are on the parabola. So I'm going to plug in 4, 3. So I plug a 4 for x and a 3 for y. And then I get 16 equals 12p. So p is 16/12, which is about 1 1/3. So that tells me that the focus will be 1 1/3 feet above the vertex. So that's where the receiver is going to go. It should be located 1 1/3 feet from the base of the dish. So that's just one example of a real world use of parabolas and how you can find where to place a receiver on a parabolic satellite dish. So that's it for our lesson today. Of course, let me know if you have any questions.